All right, time for more, right? Here we go. Take a look at that challenge question. That challenge question is really interesting, except it looks really big. I don't think I want to do it, to be honest. That looks a little big. In fact, we cannot do it right now, or I don't want to do it now until I show you a couple things. So I'm going to show you something that you're probably pretty good at. So looking at this next question, it says 10/20 times 6/8. And it says multiply the fractions by reducing first, okay? And why does that work? Again, we need to know why it works. This way you know what to do and when to do it. Okay, I'm going to reduce first. Now, it doesn't matter if I reduce up and down or diagonally across. The only way I can't reduce is straight across. I can't do numerator with numerator, but I can do any denominator with any denominator. I know you know that. It's been in your homework. It was in a couple of mods ago. But here we go. I'm going to do it. I know you hate to go up and down, so I'm going to go up and down. 10 goes into 10 once, 10 goes into 20 twice. Now I'm going to go diagonally just because I want to do something else. I live on the edge. Okay, 2 goes into 2 once, 2 goes into 6 3 times. And I get 3/8. Right, 3, that's it, right? That's it there. 3/8. That's the answer to that problem. Why does that work? It works because I'm attached by multiplication and I can reduce factors. That's why it works. So now we're going to take a closer look at some bigger problems that we can apply this knowledge to. All right, let's take a look at this. Now listen, we can multiply just like we did before. We can reduce. I'm going to tell you it gets ugly in there reducing, because even if you get different colored pens and pencils, it gets ugly with all the crossing out. So you might actually just want to reduce the numbers. It's absolutely up to you. You can reduce this way, okay, if you want, but I'm going to reduce the numbers and then deal with the letters a little differently, only because I'm afraid it's going to get really messy in there. So I'm going to go 5 goes into 5 once, 5 goes into 15 3 times. That's all I got. Now I'm going to multiply across. You don't have to do this. You could still reduce the x's and y's, but it really does get ugly. So I have 18x squared y all over x y squared. Now I'm going to reduce it. I think it's easier that way because otherwise there's a lot of crossing out going on and you kind of lose things, especially if you're old like me, you lose more. Okay, so this is x to the first power. I have more x's upstairs, 1 more. This is y to the first power. I have more y's downstairs, 1y. So my final answer is, ready? 18x over y. And I am done. Okay, and that's it. Okay, so that takes care of that. That was so easy because these were all factors. Okay, this looks a little harder, but maybe not too bad. Because notice that we have this can't be factored because they're linear. So I have this x plus y, I have this x plus y, and then I just have these numbers. So I'm going to do the same thing. I'm going to reduce. I'm going to go 6 goes into 6 once. I'm going to do the 6 into 12. 6 goes into 12 twice. Could I have done the 3 into 12? Yes. Did I want to? No. Why? I don't know. Okay. Now I could take this entire x plus y out with this entire x plus y because it matches. And now I have on the top 2 and on the bottom 3. So 2/3. And this worked because we had factors, okay? We reduced factors. Okay, coming to this problem. This problem is different because we have terms here that are not linear, terms here that are not linear. We're going to have to worry about factoring them. So that's what we're going to do, okay? So we're looking up here, and we're going to take out a GCF. It has one. It's a y. We divide each term by y, and we get y minus 4. And that's all over y to the 4th, okay? Times y cubed, that's a single term, can't do anything about that. On the bottom, we're going to factor that. I don't want to go through all the steps. That's in standard form, leading term is positive. I'm going to make 2 sets of parentheses, and I'm going to notice that my signs are different. Y squared is y and y. Now, I'm going to tell you this. This is not necessarily so, but I'm going to tell you that I like to cheat a little bit. I'm looking at y minus 4 here, and I'm thinking that maybe we want this to reduce. So I'm going to put my 4 here. Remember, we're factoring 4. I'm going to go 4 here and 1 here. I bet you I have a shot of that being correct. So let's do it. Positive 1y, negative 4y is negative 3y, so I have it. So now I'm going to take out those y minus 4s. Good night, good night. Now I'm going to deal with the y's. I'm going to go good night y, and there's 3 left downstairs. Oh, that was nice. Good night, good night. So I get to get rid of everybody. So it's except for that y plus 1 on the bottom. So it's 1 over y plus 1. That's my answer. Do I need this 1? Absolutely need the 1 because it's a numerator, not a denominator, okay? So that's the procedure to solve these, to simplify these. Shouldn't have said solve. To simplify these, I have to factor the numerator, factor the denominator, and reduce out any common factors. Once I reduce, I just multiply numerator with numerator, denominator with denominator, and then I'm done. So that's how you do those problems. I'm going to now revisit that challenge problem. Okay, here we go. This is the challenge problem. We want to evaluate this for certain numbers. Now, I have to tell you, there's no way I'm putting all the numbers in there. So first, I'm going to simplify. I'm going to take this off to the side of the board because this could be ugly. Okay, x cubed plus 8x squared plus 16x. GCF is x. I get x squared plus 8x plus 16. Try to factor this. Plus, everybody's the same as the middle, so that's plus. X squared can only be x and x. 16, I can try 4 and 4, 8 and 2, 16 and 1. I'm going to try 4 and 4. That will give me my middle term. Okay? I could write it as x times x plus 4 quantity squared, or I could write it just like that. Since we're factoring, why not just write it just like that, since we're going to try to reduce it. So that's the top of that. The bottom of this is not too bad. Just pull out a 6, GCF. We get x plus 2. Okay, so far we're good. Now let's do the next one. Okay, and the next one, 18 is the GCF. Divide by 18, and we get x plus 2 again. I'm liking those two. How about you? I like those. Now, let's take a look at this one. This looks a little bearish. Okay, bearish, like a bear, bearish. Okay, here we go. Okay, GCF looks like it's 3x, right? 3 goes into all of those. Divide by 3x. And we get x squared plus 8x plus 16. Okay? Yes, we're not done. Here we go. Oh, wait. Wasn't that what we just had before? Had I noticed that, I wouldn't have went this far, but I didn't notice it, so we're going to go. Here we go. This is what we just had before. Had I noticed it, I wouldn't have had to do that, because I could have just reduced it. That's what that is. We just did that one. Okay, so I wish I would have noticed that, but here we go. 3x, bring it over. 3x, x plus 4, x plus 4. Okay, now here we go. We're going to have some fun. We're going to take care of the numbers first. So I want to keep you guessing. Do you know you could do this? 3 times 6 is 18. Everybody's out. You know why? Watch. 6 goes into 6 once. 6 goes into 18 3 times. 3 goes into 3 once. 3 goes into 3 once. All gone. Okay, but I could have did it in one shot. Okay. Good night, X's. And now for the big stuff. I love the big stuff. X plus 2. X plus 2. X plus 4. X plus 4. X plus 4. X plus 4. Whoa! We get 1. I love that question. I love that question. I love that question. So let me just kind of introduce the rest of the question to you. It says, evaluate when x is 10. It says, evaluate this when x is 10, when x is 3.2454, and x is 1/2. When, oh, that was ugly. That's a new marker that's ugly. Ugly. Okay. When x is 10, guess what this is? 1. You plug in 1. You plug in 10 in here, you get 1 back. I love this. So the expression is 1. When x is 3.2454, guess what the expression is? Yes, the expression is 1. Okay? When x is 1/2, guess what the expression is? Yes, 1. I love this. Okay, when's the only time we have to worry? Look closely at the factored form. We have to worry at -2, because at -2 this will be undefined. We have to worry about -4, because at -4 this will make this 0 and this 0, so it'll be undefined. We also have to worry about 0. So it will always be 1 unless you have -2, -4, or 0. These are undefined points. So no matter what now I didn't ask you for this. This is free. This is a free one. This is on me. Okay? X is, the expression will always simplify to 1 unless you have -2, -4, or 0. Then the expression is undefined. I love that. I love when you take a nice big question and it is undefined. I just love that. Okay, so there are 3 questions in your notebooks. You try them. Okay, let's see how you did. Okay, and again, this was up to you how you actually wanted to handle this, but I'm going to try to make it the less reducing that I can as far as it looking funny. So I'm going to rewrite this because this is really over 1. And now I'm going to reduce out the numbers, okay? So 7 goes into 7 once. 7 goes into 14 twice. Okay. I'm trying to figure out what, well, you know what? There's nothing to reduce on top, so I'm just going to do this. Z squared goes into Z squared once, and there's 2 left downstairs because it's bigger downstairs. So I have a lot of junk. Let's see what I shouldn't call it junk, huh? But it's a lot of junk. So let's see what I got. I got 18 times 2, and 18 times 2 is 36. I'm getting rid of that one. I got 36. Better. X to the 5th, y to the 4th. That's all I have on top. On the bottom, I have z squared, and I am done. That is it. So that makes that pretty easy. Let's look at this guy. I think this guy's not bad. The third one is a big guy, but this guy's not bad. So let's see what we got. Parentheses first, we have z squared over 10. Here we have 10. I'm going to factor that because I want to try to reduce. So I'm going to pull out a c, and I get c plus 7. Oh, this is going to be fun. This isn't bad at all. Okay, so I'm going to reduce. Good night, 10s. Good night, c. There's a c left upstairs. So I have finally, as my final answer, c over c plus 7. Can you reduce the c's? Please be saying no, because the answer is no. Why is the answer no? Because this c is a term, and I can't reduce terms. So the final answer is c over c plus 7, and you're done with those 2 problems. We're going to do the third one in a second. Okay, let's see what you got. This was a big one. If you got this one, pat yourself on the back, because this was a biggie. Okay, I'm going to come here. I'm giving myself some room here. So I'm going to take the big one, 3x cubed minus 9x squared minus 30x, put it here. Factor out of 3x. That's like, I keep factoring out 3x. Seems like that's very common. Okay, and I get x squared minus 3x minus 10. Okay, so now I'm going to factor that. 3 terms. Signs are different, x and x. 10 can be 5 and 2, 10 and 1. I'm going to try 5 and 2. I'm going to put the 2 here, the 5 here. That's positive 2x, negative 5x, which gives me a negative 3x. So I got it. That's the factors of Big Mama. Okay, so it's 3x times the quantity x plus 2 times the quantity x minus 5. For this one, I'm going to do this one right here. 2x squared minus 8. Factor out of 2, and I get x squared minus 4. Not done. Difference of 2 squares. So I'm going to factor that. X and x plus and minus 2 and 2. So that's what goes on the bottom. Times. This is easy. 6 times the quantity x minus 2, taking out a GCF of 6. And finally, the bottom is already factored for me. Thanks, somebody, for me, huh? X plus 1 quantity squared. Now I get to do the most fun. I get to reduce everything that I can reduce. I'm going to take care of the numbers on the outside first. Okay, numbers first. 3 into 3 goes once. 3 into 9 goes 3 times. 3 into 3 goes once. 3 into 6 goes twice. Oh, look, I can keep going. 2 into 2 goes once. I can just probably go to forever. Okay, that takes care of all my numbers. Now I'm going to deal with the x's. Good night, x, and there's an x here. Now I'm going to deal with my big guys, my big guns. X plus 2, x plus 2, x minus 2, x minus 2. On the top, all I have is x minus 5. That's it. On the bottom, don't forget this guy, x times the quantity, x plus 1 quantity squared. That's all I got. Awesome problem. If you did that, pat yourself on the back. That was good. It's not really going to get any harder than that. So that's pretty cool. All right, now I have a challenge question for you. We're going to take a look at that in a second. Do you ever wonder why I really pick these questions out? I know you're wondering, yes, why do you? But there is a reason. Let's take a look at this. Find the width of a rectangle if it has a length of 2x over x squared minus 49 feet and an area of 7 over 7x minus 49 feet. So, you know, that's nice, but I don't even know what I said. So here's what we're going to do. We're going to do length times width equals area, or area equals length times width, it doesn't matter. We want the width, so we don't know the length. So the length is 2x over x squared minus 49. And the width is, I'm going to make it w. I can't make it an x, because if I make it an x, you're going to think that's different now. Okay, and that equals the area of 2 over 7x minus 49. This is what I want. How would we possibly solve this? Well, how did you solve this when it said 7w equals 14? You solve it by dividing. You're going to actually take this and divide, right? So what we and this is gone, and then you just get w. So what we really have here is we really want to just divide that. We're going to do that. So we're going to talk about now, we've done multiplication. Now we're going to talk about we have this need for division. We're taking 2 over 7x minus 49, and we're going to divide it by 2x over x squared minus 49. So now we're just going to go one step further instead of multiplication and do division. And how do you do division? Well, you remember, you flip, keep, change, flip, or multiply by the reciprocal of the divisor. So this is the divisor, you multiply by the reciprocal. Keep, change, flip. Okay, remember there was my teacher who used to be able to stand up and flip? Okay, who cares? I can't do it, so it doesn't really matter. Okay, so here we go. We're gonna change this to a multiplication problem. So first I'm gonna do that. Times, flip, need the reciprocal. Now we have what we just did. Now we have to factor and reduce. So this is 2. Factor out the 7. We get x minus 7. On the top here, we have the difference of 2 squares. And I know you've been factoring for a while now, so you can do this. And now we just reduce. You know this. So we can extend what we know by just plugging in and figuring it out. Never think, oh my God, I read a problem, I'm going to have to know how to do that problem. That's not so. You have to think about it. Okay, that's what we do. We just sit there and think, what do I know? What can I do? And then the x minus 7, good night. So on the top, we have x plus 7. And I don't remember what the units are. They might have been feet. X plus 7 over 7. And I believe the units were feet. Yes, it was. So it was feet, and it was the width. So the width is x plus 7 over 7 feet. Awesome problem. And I cannot reduce those 7s because they're terms. You know why I like this problem? It's a problem that when I looked at it, I went, I don't know. And then I just plugged in what I know, took all the information I knew from lessons before and tried to figure it out. So that's what I have. So now we're up to division. Don't get flip happy. You only flip when you have division. And you use the reciprocal of the divisor, this second number, the divisor, okay, which you're dividing by. And so there's some questions for you to practice in your workbook. There are 3 of them. You try those, click back when you're ready, and we'll solve those together. All right, let's see how much you know. How much do you know? All right, this is 2x quantity cubed over 2x cubed divided by this. Okay, we're going to have to flip this, use the reciprocal. Reciprocal. Let's play with this one for a minute. These are different. Here the only thing being cubed is the x. Here the whole thing is being cubed. We can do, yes, power to power. So this is 2 cubed x cubed. Remember that whole thing? Come on, power to power. You've been doing it in your homework. I know you remember it. So let's write that in there. 8, that's nice, 8x cubed over 2x cubed times, we're going to flip, times 16x over 6x squared. Okay? Now we're going to reduce. You ready? Here we go. 2 into 2 goes once, 2 into 16 goes 8. 2 into 6 goes 3, 2 into 8 goes 4. Anywhere else to go? I don't think so. Now we got the letters. You ready? Letter fun. Good night. Match. There's one more x downstairs. So that's it. We got 1 times 4 is 4 over 3x. How'd you do on that one? We have 4 over 3. Oh, nope, I screwed up. Help me when I screw up. There's an 8 here. This is what happens when you get old. You miss it. 8 times 4 is 32. I'm going to fix that for you right now. 8 times 4 is 30. That's why I keep looking. That's why I like different colors. Remind me not to do that again. 8 times 4 is 32 over 3x. Now we're done. Okay, let's take a look at this one. This looks like a beauty. I'm holding the colored one in my hand here. Okay, we're going to change this to multiplication. This is over 1 right now, so when it flips, we get this. All right, ready? X minus y quantity squared. There's nothing to factor there. That means what I could do there is I can write it twice if I want, or I could just leave it that way. Absolutely up to you. You could have left it, or you could write it twice. I'm going to write it twice. Why? I don't know. I feel like it. Okay, this is the difference of two squares. No GCF. Don't forget to look for the GCF. No GCF. Okay, so here we go. X plus y. X squared is x and x. And y squared is y and y, different signs. No GCF, but we have standard form. 3 terms, make 2 sets of parentheses. X squared is x and x. This negative tells me my signs are different. So 1 plus, 1 minus. 2y squared can only be 2y and y. Let's make sure it's in the right place, but this is 2xy positive. This is negative 1. I'll get that positive that I need. Now it's time to bring out the green. Okay, we're going to reduce. X minus y, x minus y, x minus y, x minus y. And that's it. So we have 1 over x plus y, x plus 2y. And we are now done. Hope you did well on that one. We have 1 more left. End of another lesson when we finish the next one. Okay, let's see what you did on this problem. All right, so I'm first going to start by flipping this to multiply by the reciprocal of the divisor. Okay. Funny, it almost seems to me like I've seen this problem before. Here we go. Times flip y squared minus 4y plus 3 over y squared minus 3y plus 2. All right. Now I'm going to keep this. Do not flip here. Do not get flipped crazy because we're multiplying here, not dividing. So we're just going to keep this, y minus 2 quantity squared over 2y. Now, here we go. You feeling the rash? Because I'm feeling the rash right here. That's backwards. I really don't like that. I'm getting a rash. Okay. If I rewrite that, that's how I want to see that. And then I'm going to factor that really kind of nicely. Okay, 3y are factors. There's nothing to factor there. So 3y over, pull out a negative 3. When I pull out a negative 3, I'm dividing by negative 3, so all the signs change. This is y minus 3 times, I'm going to factor this. We're in standard form. I checked for the GCF, no GCF. Okay, so everything's the same sign. They're both negative, same negative. Y squared is just y and y. 3, I'm going to try 3 and 1. Negative 3y, negative 1y, that'll give me my negative 4y, so I have that. Same thing on the bottom, y and y, but now they're, again, the same sign, and they're both negative, again. 2, I'm going to try 2 and 1. It has to work, I hope, or I can't reduce. Negative 2y, negative 1y, negative 3y, good. Nothing to factor here. If you'd like to, you can write this twice. Absolutely up to you. Absolutely up to you. Your call. Your call. Don't care. Okay, here we go. I'm going to reduce. I'm going to take care of the outside numbers first. Are you ready? Okay, the numbers. 3 goes into 3 once, and there's a negative 1 there. That's okay. Now, these are separate factors, so I just take out the y. I don't subtract. I just reduce the y's. So good night, y's. Now I'm going to go for the letters. Y minus 3, y minus 3. Y minus, this is my favorite part. Y minus 1, y minus 1. Y minus 2, y minus 2. Anything else? I don't see anything else. So, on the top, we have y minus 2. And on the bottom, don't forget this is a negative, we have negative 2. And that's it. I am done. That big, long, horrible thing comes out to this. And when is this fraction undefined? Look at it when you see its factors. This is y minus 3 here. So that's undefined when y is 3. This is undefined when y is 2. This is undefined when y is 1. This is undefined when y is 0. So there's lots of places it's undefined. 0, 1, 2, 3. But for all those other numbers, this is what this expression is equal to if we plug in a number. No matter what number we plug in, it would be equal to this, except for those that make it undefined. Absolutely incredibly great problem. That's the end of this lesson.